class. Today I wanted to go over the z-scores, proportions, and percentiles worksheet I had given out in class a couple weeks back. So we're going to go over the answers. The key and the PowerPoint are posted online. The key and the original worksheet are posted online. So first off, let's remember what a z-score is. So a z-score in a normal distribution, so let's draw a beautiful normal distribution. A z-score in a normal distribution measures how many standard deviations you are away from the mean. And typically we aren't more than 3 standard deviations away from the mean. Sorry, that should be a minus. Minus 3 standard deviations. So a normal distribution of scores has a standard deviation of 10. Okay, so here we know we have a normal distribution. Our standard deviation sigma is 10. And I want to find the z-scores corresponding to each of the following values. I want to score a corresponding value to something that's 20 points above the mean, 10 points above the mean, 15, and 30. So a z-score equals a data value minus the mean over the standard deviation. So in this case, if I have something that's 20 above the mean, let's pretend our mean is 0, and I go 10, 20 points above the mean, right? We can see that that is a standard deviation of 2, right? We went 1, 2, but let's calculate it. So I have z equals 20 over 10, which is 2. So I have a z-score of 2. What if I have a score that's 10 below the mean? That'd be negative 10 below 0. That means I would have a z-score of negative 10 divided by 10, which is negative 1. What if I want to know the z-score of something right here like 15? Okay, so I take z equals 15 minus our mean of 0 divided by 10, so I get a z-score of 1.5. And what about 30 points below the mean? Again, my mean is 0, so I have 30 minus 0 over 10, which is 3. So this is how we calculate z-scores. Now, for each z-score below, I want us to find the percentile of individuals scoring at or below this value. So remember, when you're given a z-score, that measures how many standard deviations you are away from the mean. But when you look it up in the z-table, what it tells you are, sorry, that's a minus. What it tells you is the area to the left of that point. So let's go ahead and mark where I have a z-score of 0.47 right here. So if I look this up in the z-table, it's going to give me this green area over here. So we're going to find the area of the green over here from our z-table. So I go to our z-table and I find a value of 0.3192. Okay? So that's our percentile. What percentage would that be? Remember, this is the area, and I can convert this to a percentage, so I'm going to say 32%. Now, let's take a look at when z is 2.24. So I'm right here. I'm going to look up the area in the z-table, and it's going to tell me all of the area less than, with a value less than 2.24 standard deviations. So I go to the z-table, and I get a z-table value of 0.9875. Okay, so I'm going to round that to 99%. That means the area right here, all that's touching, that's orange, is 0.9875. Now, for each z-score below, I want to find the proportion of cases falling above that z value. So if I have my normal distribution, I'm trying to find the area above. So let's take a look. If I have z equals 0.24, that's like right here. I'm trying to find the area over here. Okay. Now I need to remember that the area under the normal curve equals 1. So if Bobby, you can't sit on my notes. Silly cat. So if I go to my z-table, for the z-score of 0.24, I find a z-table value of 0.5948. So that means the area over here is 0.5948. I'm going to go ahead and round that to 0.60. So I would find, if I took 1 minus 0.60, right, like I want to take the whole area is 1. I want to subtract what I found from 1. That gives me 0.40 or 40%. Next, if I have a z-table value of negative 2.04, a z-score of negative 2.04, I'm going to look that up in my z-table, and it will give me a value of 0.0192. So here I am at negative 0.207, and I want to know all of this. I want the area above this. And I look up and find that this little tail right here has an area of 0.0192. So we'll round that to 0.02. Take 1 minus 0.02. So the proportion of cases falling above this z value is 0.98. Or 98%. So for problem 4, for each of the z-scores below, we want to find the area between the mean and the z-score. Now what's really important to remember is that our mean divides our normal distribution in half. So the area on each side is 0.5. So let's take a look at z equals 1.17. So I'm going to go to the z-table, and I'm going to look this up, and I'm going to get a value of 0.879. And this makes sense, right? If I have a positive z-score, it's above the mean. So the area to the left of 1.17, the entire area, is 0.879. Now, I only want to know the area between the mean and the z-score. So I'm only looking for this area right here. So what I'm going to do is I'm going to take 0.879 minus 0.5, this area right here, and that should leave me with what's left in this area. So I get 0.379 is my area. This time it's asking us to find the area, not the probability, so I'm going to leave it as a decimal. For our next problem, erase this. For our next problem, we're going to look at a z-score of negative 1.37. So this z-score will be below the mean. Okay, so if I get a z-score and I look this up, I get a z-table value of 0.0853. And I'm trying to find the value between the mean and this z-score. So I, by looking at the z-table value, found the area of this little section right here. That's 0.0853. Now I know the mean divides my entire normal distribution in half. So the area over here and all of this is 0.5. All I want to know is the area in here. So I'm going to take 0.5 minus 0.0853. So 0.5 minus this is going to leave me with what's in here. So I get an area of 0.4147 is my final answer. Problem 5 asks us, a patient recently diagnosed with Alzheimer's disease takes a cognitive abilities test and scores a 45. The mean on this test is 52 and the standard deviation is 5. What is the patient's percentile? Okay, so let's go ahead and set this up. I have a normal distribution with a mean of 52. I have a patient who scores a 42, and I want to know what percentile, a 45, and I want to know what percentile this marks, okay? If I find out the area from 45, less than 45, this will tell me what percentage of patients would score less than 45, and therefore our percentile. So I'm going to find my z-score. To find a z-score, you take your data value minus the mean over the standard deviation. So I'm going to take 45 minus 52 divided by 5, and I'm going to get negative 1.4. I take this z-score and I look it up to get a z-table value of 0.0808. So that tells me the area over here is 0.0808. That's the area less than 45 in our normal curve. So this is going to mark the 8th percentile, or 8%, right? 8% of patients scored less than a 45, so 45 marks the 8th percentile. Okay, let's take another percentile problem. Oops. So a 5th grader takes a standardized achievement test that has a mean of 125 and a standard deviation of 15, and they score a 145. What is the child's percentile? Okay, so here we go. Mean of 125, they score a 148. And what is their percentile? So I'm going to take my data value, which is 148. Sometimes that's represented with an X, minus our mean over our standard deviation. That gives me 1.53. If I look that 1.53 up in a z-table, I get 0.9373. So the area less than 148 over here is 0.9373. So that would be about 94% of students score less than 148. So the 94th percentile. See, I just converted this to a percentage and rounded. All right, for problem 7, Pat and Chris both took a spatial abilities test that has a mean of 80 and a standard deviation of 8. Pat scored a 76 and Chris scored a 94. So what proportion of individuals would score between Matt and Chris? Let's sketch this out. So my mean is 80. I've got Pat over here with a 76, and I've got Chris with a 94. And I want to figure out this area. Now remember, when I find a z-table value, that tells me the area less than this value. So for 94, my z-table value will tell me all of this. And for 76, my z-table value will just tell me this. So if I take my z-score for my z-table value for 94 minus our z-table value for 76, it's going to leave me with just what's in here. So in this case, I have to calculate 2 z-scores. So let's do 94 first. Z equals 94, which is our value, minus 80 divided by 8. That gives me a z-table value of 1.75. sorry, that's a z-score of 1.75. That means 94 is 1.75 standard deviations above the mean, which is 80. And I get a z-table value of 0.9599. Next, I'm going to find the z-score for 76. I take 76 minus 80 over 8. That gives me a z-score of negative 0.5. So 76 is half a deviation less than the mean because it's negative. I look this up in my z-table, and I find a z-table value of 0.3085. So now, in order to find what proportion, so they want it as a percentage or a decimal, I'm going to need to take 0.9599 minus 0.3085, and that gives me 0.6514. So 65% of individuals would score between Pat and Chris. For problem 8, the Welcher Adult Intelligence Test is composed of a number of subtests. On one subtest, the raw scores have a mean of 35 and a standard deviation of 6. Assuming these raw scores form a normal distribution, I want to know what proportion of raw scores are between a 28 and a 38. Okay, so again, here I have my normal distribution with a mean of 35, and I want to know what the area between the scores of 38 and 28 are. So just like the previous slide, if I look up the area for 38 in a z-table, it's going to give me all of this. If I look up the area for 28, it's going to give me all of this. So I'm going to take the z-table value for 38 minus the z-table value for 28 in order to find our answer. So let's go ahead and find the z-score for 38. That means z equals 38 minus our mean over our standard deviation. I get a z-score of 0.5, which gives me a z-table value of 0.6915. And if you're uncertain as to how I found a z-score of 0.5 and looked that up in the z-table, pause this here and take out your z-table. I've also posted one on the website, and make sure you know how to find a z-value. Next, I'm going to find the z-score for 28. I'm going to take z equals 28 minus 35 over our standard deviation, which is 6. That should have been a 6 under there. Which equals negative 1.17. So I look that up and I get a z-table value of 0.121. So now in order to find the area in between 38 and 28, I'm going to want to take 0.6915 minus 0.121, and that'll give me 0.5705. So I can convert that to that 57% of raw scores are between 28 and 38. Now, using the same distribution, I want to know, what percent of raw scores, same mean, but this time are between 41 and 44. So now I'm just trying to find the area of this little sliver right here. So I'm still going to take the area of 44, the area less than 44, and subtract from that the area less than 41. So again, I have to calculate two z-scores. So let's go with 44 first. 44 minus 35 over our standard deviation, right? We're just finding a z-score. It's the same process every time. Gives me a z-score of 1.5. I look that up in a z-table, and I get a z-table value of 0.9332. Next, I need to find the z-score for 41. So I take 41 minus our mean, which is 35, over our standard deviation, which is 6. That gives me 1. So I find a z-table value of 0.8413. So now, in order to solve this problem, I'm going to take 0.9332 0.332 minus 0.8413, which equals 0.0919. So about 9% of raw scores are between 41 and 44. Now, what if I want to know which number represents the 65th percentile? So that's kind of saying what number separates the lower 65 of the distribution. So here I have my normal distribution with a mean of 35, which I know divides my data in half. So I've got some value over here, and I want to know what value would give us a z-score of 0.65. Because here I have 65% of the data less than this x value. So we're going to work backwards, okay? I'm going to go to the z-table. Let me move this. So we have some more room. I'm going to go to the z-table. And remember, the z-table scores tell us the area under the normal curve. So I know my area. I'm going to get a z-table value of 0.65. I'm going to go in my z-table and I'm going to work backwards. I'm going to find the z-score that goes with 0.65. And the z-score that goes with 0.65 is 0.38. Now we're going to work backwards. We have this formula that our z-score equals our data value minus our mean over our standard deviation. Well, I know my z-score, right? That's going to be 0.38. 0.38 relates to an area of 0.65. I know my mean. I know my standard deviation. I don't know my data value, so we're going to represent that with an x and work backwards, okay? The first thing I want to do to solve for x is I need to isolate x. I need to get x all by itself. The first thing I'm going to do is multiply both sides of the equation by 6, because remember when we're solving an equation, what we do to one side, we need to do the other side. So that gives me 2.28 equals x minus 35. Then I add 35 to both sides. That gives me 37.28 equals x. So 37. 37 represents the 65th percentile. 36.7 is the score that separates the lower 65% of the distribution. Now I'm going to do the same thing for the 90th percentile. I want to know what score separates the lower 90% of the data. So I take my z-table value of 0.9, right? That's the area under the curve. I go to my z-table and I find that the z-score associated with an area of 0.9 is 1.28. So now I have 1.28, that's my z-score, equals our data value, which we don't know, minus our mean over our standard deviation. And I go ahead and solve this to get 42.68 equals x. So 43. 43 is the cutoff for the 90th percentile. Okay, problem 9. Scores on the SAT form a normal distribution with a mean of 500 and a standard deviation of 100. What is the minimum score necessary to be in the top 15% of the SAT distribution? So this is a little bit different. If I want to be in the top 15%, I want to have the area over here of 0.15, okay? Now remember when we look up a z-score, the z-score tells us the area less than x. Well, and the total area under a normal curve has to add up to 1. So if I want to find the area over here, I can take 1 minus 0.15, which equals 0.85. So I have an area of 0.85. that means my z table value is going to be 0.85, right? Because I'm going to find the area less than that. This is why it's so important to sketch this out, beyond important, right? To make sure you're looking at the top 15%. Otherwise, if you'd used the lower 15% by accident, you would have gotten this problem wrong. So I go to my z table of 0.85 and I find a z-score of 1.04. So now I take 1.04 equals our data value minus our mean over our standard deviation, and I solve for x. I multiply both sides by 100, right? That's what we do to get our x all by itself. That gives me 104 equals x minus 500. I add 500 to both sides. That gives me x equals 604. So a score of 604 would be your minimum score necessary to be in the top 15%. Next, I want to find the range of values necessary to be in the middle 80%. We'll do a quick sketch right here, right? So here's my mean that divides everything in half, and I want to find the middle 80%. So if the area in the middle is 0.8, right, that means I've got 0.10 in each of these tails. So I need to find the area, I need to find the z-scores associated with the area of 0.10. And if I take 0.10 plus 0.80 over here, this whole area has an area of 0.90. Okay? So in this case, I have to work backwards twice. I have two z-table values. Z-table of 0.10 and a z-table of 0.90. Okay? And I'm going to use that. I'm going to take the area. I'm going to take the z-score for each of these, and that will define my range of values. So I look up 0.10 in the z-table, and it gives me a z-score of negative 1.28. I look up 0.90 in the z-table, and it gives me a z-score of negative 1.28. I solve both of these, right? Positive 1.28. I have negative 1.28 equals our x value, which we're trying to find, minus our mean over our standard deviation, which is 100. I find that x equals 372. I do the same thing over here. I've got 1.28 equals x minus 500 over 100. I solve this and I get x equals 628. So the range of values that define the middle 80% are from 372 to 628. And I do have the key to this posted on our class website, the key to this worksheet. Remember, this is the Z-Scores, Proportions, and Percentiles worksheet if you have any questions on how I solved that problem. Now, last but certainly not least, we've got problem 10, okay? For a normal distribution, I want to find a z-score that separates the distribution from follows. So all I want is a z-score here. I don't have to solve for a given data value. But for all of these, we're going to want to sketch it out. So I want to separate the highest 30% from the rest of the distribution. So I want this area over here to be 0.3. Remembering the total area under a normal curve is 1, so the area over here would be 0.7. So I have a z-table value of 0.7, and if I go into my z-table and find the z-score associated with 0.7, that's going to be 0.52. Next, I want to separate, let's change color. I want to separate the lower 40%. Okay, I want a z-score associated with separating the lower 40%. That would just be this area right here, right? That gives me a z-table value of 0.40. I take that to my z-table. I find it that area relates to a z-score of negative 1.75. Last but not least, I want to separate the highest 75% of data. That means the z-score over here would be associated with an area of 0.25 because I'm looking for the highest 75%. I have a z-table value of 0.25. I take this to the z-table and I find a z-score associated with this is negative 1.96. So that completes a step-by-step walkthrough of how to solve all the questions on the z-scores, proportions, and percentiles worksheet. That was from a worksheet earlier on in this semester. If you have any questions, feel free to comment. Feel free to shoot me a message. I hope this helps.